The following is a tutorial on calculating pH or pOH given the concentration of an acid or a base. Okay, so the first problem reads, what is the pH of a 1.0 times 10 to the negative 3 molar solution of HCl? So the first thing that we need to do is decide whether or not HCl is an acid or a base. So if we were to write down the ionization of HCl, in other words, what it would break down into if we put it in water, we would get, okay, this would be made up of hydrogen and chlorine. So the ions would be H plus and Cl minus. So the fact that when we put this in solution, it produces hydrogen, that means that we have an acid. And this is considered a strong acid. So whatever the concentration of the acid is, that will also be the concentration for hydrogen. Okay, so we are given the hydrogen ion concentration because we determined that this is a strong acid, so we have the concentration of hydrogen, of the H plus that was given off. And the question asks us to find pH. All right, so we look over at our equations. Now we know that pH means power of hydrogen. So it would be a measure of this concentration of hydrogen. And we do have an equation that relates those. So on this side we have what you'd be plugging into the equation, and this is what you get. So if we plug in hydrogen ion concentration into this equation, we will get pH. So we have pH equals negative log of 1.0 times 10 to the negative 3 molar. And when you plug that into your calculator, you should get an answer of 3. So pH equals 3. Let's try another problem. What is the pOH of a 2.5 times 10 to the negative 2 molar solution of NaOH? So if we took NaOH and we wanted to show its ionization, you should be able to recognize that, first of all, this is an ionic compound. It's a combination of a metal with a nonmetal. And we see that there are more than 2 elements in here. So OH you should recognize as a polyatomic ion. So if we put this in solution, it's going to break into sodium ions and hydroxide ions. So by definition, this would be considered a base because it's going to increase the concentration of hydroxide if we put it into a solution. So we are asked to find pOH, and we were given the concentration of a strong base. So that means that this concentration is also the concentration for hydroxide. So if you have an acid, it's the concentration of a strong acid, that is the hydrogen ion concentration. If you're given the concentration of a strong base, that is the hydroxide ion concentration. Okay, so pOH is the power of hydroxide, and we do have the concentration of hydroxide, so we can tell how powerful it is. We can use this equation. Okay, so we're going to be able to plug in hydroxide and we're going to get pOH out of it. So pH equals negative log of 2.5 times 10 to the negative 2. And when you plug that into your calculator, you should get an answer of 1.60. All right. In the next problem, now things are going to get a little bit more complicated. So question reads, what is the pH of a 4.0 times 10 to the negative 8 molar solution of RbOH, which is rubidium hydroxide? Okay, this hydroxide right here will already tip us off that we are dealing with a base, and this is a strong base. So this concentration, since we're dealing with a strong base, that's the concentration of hydroxide. But the question asks us to find pH. So we're looking for the power of hydrogen, yet we're given the concentration of hydroxide. So in order to solve this problem, we're going to need to do this in 2 steps. So as of right now, the equation that we're able to plug this information into is pOH equals negative log of hydroxide ion concentration. So we're going to go ahead and solve for pOH first. So pOH, again, that's because we're dealing with a strong base, not an acid. Negative log of 4.0 times 10 to the negative 8 molar. And when you plug that into your calculator, you should get 7.40. All right, so now we have pOH. So a really easy way to solve this would be to use this equation. Okay, so pH plus pOH is 14. So if pH plus pOH equals 14, we're just going to subtract, and then you should get an answer of 6.6. So pH equals 6.6. Okay, there's no units for pH, we'll just say pH equals. All right, next problem. What is the pOH? So we're looking for pOH in this scenario of a 4.0 times 10 to the negative 8 molar solution of HI. Okay, so we have hydroiodic acid. If we put this in solution, it's going to break up into hydrogen ions and iodine. So it gives up hydrogen in solution. That makes it an acid. So that means we have the concentration of hydrogen. Okay, we have a concentration of a strong acid. That will also be the concentration of hydrogen ion. 4.0 times 10 to the negative 8. Okay, so just like before, we don't have the information right now to find pOH. We do not have an equation that relates hydrogen ion concentration to pOH. Instead, it relates it to pH. So you're going to solve it the same exact way. pH equals negative log of 4.0 times 10 to the negative 8. Okay, and that will give us our power of hydrogen because we use the concentration of hydrogen. I used the same concentration as the last problem, so in this case now we have pH equals 7.40. And again, we're going to plug that into the equation where pH, oops, that is our pH, 7.40 plus pOH, so that's what we're looking for, is equal to 14. So in this scenario, you'll get pOH equals 6.6.